Assalamu alaikum warahmatullahi wabarakatuh, grade 4. Hope you are enjoying your week, and in this video, inshallah, we are going to talk about how is information transferred from place to place. But before starting anything, let's start with the dua. اللهم لا سهل إلا ما جعلته سهلا فأنت تجعل الصعب إذا شئت سهلا يا رب العالمين. اللهم إني أسألك فهم النبيين وحفظ المرسلين وإلهام الملائكة المقربين. اللهم إني أسألك قلبا خاشعا ولسانا ذاكرا شاكرا إنك على كل شيء قدير. Let's start. How is information transferred from one place to another? By the end of this lesson, you should be able to describe different ways and codes and signals that are used to transfer information from one place to another and from one person to another. In page 201, you are going to find this question. How has the way we receive information changed over the years? Information through the internet, through the web, through mobile phones, through emails, through our books, through everything around us. How could we receive different information, and how the ways we receive information changed over years? In this slide, you can find out. From 1960 up till now, all of the media or the ways we receive information evolved or evoluted or developed. Can you see how the television looks like in 1960 and how it looks like nowadays? It's completely different. And radios and internet, from 1960 to 1980, we didn't have any internet, but nowadays all of us are holding internet in their hand through tablets, mobile phones, smartphones, smartwatches, and everything around us. So all of the media and all of the different ways of getting information or transferring information are evolved and developed up till now, and still in its way to evolve more and more and to develop more and more. Communication tool in the past and in the present, not just today or not nowadays, but it was from long ago. History of information transfer. Even our ancient Egyptians, they transfer information to us through their paintings and their language, the hieroglyphic language, to communicate and record their history on walls and on their papers. So we be able to know our ancient history. Even the ancient Chinese people, they used to communicate together using smoke. Those days there were so many battles. So when soldiers try to communicate together as they are far away from each other, they make smoke signals to communicate across distance. Native American also, they use smoke to send signals and communicate. Also drums. Drums are an ancient way to communicate, but they are still using it, and it's still an important way in the culture of West Africa. One is by land, two is by sea. This sentence was used in Paul Revere's right to let people that the British are coming, that the British were coming using lanterns. When they turn on these lanterns in the church, they are telling the people that the British are coming. And the British people on those days were kind of enemies to those people. So this was a kind of communication, turning on the lantern to tell people that British were coming. In page 203, you can find this activity or this exercise. Choose a word or phrase that make each sentence correct. We have hieroglyphics, lanterns, talking drums, smoke signals. One of the earliest way of sending messages was through the use of, think about it, this involved drawing pictures on paper. Which language involved drawing pictures on paper? To send signals across long distance, the ancient Chinese used to alert the troops that enemies were coming. Excellent. One of the earliest way of sending messages was using the hieroglyphic language, and this involved during pictures on paper. And the ancient Chinese used to send smoke signals to tell the people that the enemies were coming and to tell the other soldiers. Even the eyes, when your cat looks to you in this way, you know that it loves you, or maybe it needs some food. So this also a kind of communication. Newer ways of communication is the International Morse Code. The International Morse Code. What is the Morse Code? Morse Code is a series of dots and dashes. Each series make up a letter like this. A is dot dash, B is dash dot dot dot, C is dash dot dash dot, and so on. In page 204, you can find the meaning of that. The telegraph code, they also call this Morse code the telegraph code. The telegraph code is called Morse code. It's a series of dots and dashes, each making up a letter. Each series make up a letter. An operator is one place tap out a message. It travels through wires to another location. These codes travel through wires to another location. A second operator, the second person that's receiving these codes, decodes the message. Decode the message means translate it. Operator needed to be skilled so messages could be sent quickly and accurately. If you don't know this language, or if you don't know the codes, you cannot decode it. So you need to be very skilled and you know this language very well to decode it. So you decode or translate the message correctly without any mistakes. In page 204, we can find this question. Telegraph messages, which is Morse code, were very popular, but not always reliable. Very popular, but not always accurate and not always correct. Why? Research how telegraphs were sent and name some ways a message might be miscommunicated or misunderstood. What do you think? What will make the message miscommunicated or misunderstood? Maybe if you don't know the accurate code, if you missend it, or if you could not decode it or could not translate it. If the operator encodes the letter wrong, or the second operator, the first operator is the sender and the second operator is the receiver, or the second operator decodes or translates the letter wrong, the message could be miscommunicated or misunderstood. Here you're having your Morse code, so may you translate these phrases? Let's translate it together. But I want you to know that the sentence is switched. The first is its beginning is at right and the end of it is on left. 2 dots is which letter? I, M, I, S, S, E, D, U. So the phrase or the message is I missed you. Take your time to decode the other 2 messages, and remember it's inverted, not from left to right, it's from right to left, like the first one. In page 205, you can use those codes to write your name in the space below, write your name in Morse code, and be careful to write it correctly, because if you miss a dot or a dash, you will write a completely different name. Codes. Can you give more example of codes? Like light, flags, and smoke. What is the most important thing to consider when you're choosing a code to use? You must understand it. You must understand this code well, and the receiver also. If you send me a code that I do not understand, how will I decode it, or how will I translate it, or how will I understand it? I will not be able to do so. Another application for codes like the Enigma machine. This machine they use it during wars to send messages that cannot be understood by anyone but the receiver, the one that you are sending the message to. This was the end of the session, and now we're having an activity. These tables I want you to color the boxes that have ones, just the boxes that have ones, to see what the message says. If you did so, you will find this picture, a spider picture. Actually, this wasn't just a game. This is how the images we watch every day on any application, even on any portrait or something, is formed. The picture that we print from a device like the computer or something, or the mobile phone. Have you ever looked closely at a picture using a magnifying glass? If so, you may have seen that the image is made up of millions of tiny dots, very small dots and squares. Each dot that made the picture is called a pixel. When there are a lot of pixels in an image, the image is very sharp and clear with high resolution. If there are few pixels or small amount of pixels, like in this image, if you count the squares, you will find small amount than this. This have a lot of squares, a lot of pixels. That's why it's clear and sharp with high resolution. While this was a small amount of pixels, that's why it's not clear and blurred. So we can say the more the pixels, the clearer the image. Which picture has more pixels or more resolution from Obama's picture? Excellent, it's A, because it has more pixels. I need a magnifying glass to see them, but here I can see the pixels on those images. That's why they are not clear. They have small amount of pixels. So a few pixels that make the image with low resolution and blurring, as well as those two cats with low pixel and low resolution. Another game. Here we have those 6 boxes. In the first box we have 1 dot. The second box we have double the first, 2. The third double the second. Double 2, 4. Double 4, 8. Double 8, 16. Double 16, 32. So we have 1, double 1, 2, double 2, 4, double 4, 8, double 8, 16, double 16, 32 in each box. If we want to collect number 13 from those boxes, which boxes will we choose to collect number 13, to collect 13 dot? Excellent, it's gonna be 8 and 4 and 1. 8 plus 4 plus 1 equals 13. What about the other boxes? We didn't choose them. We gave number 1 to the box we choose. The other boxes will just take 0. So now we get the code of number 13, which is 001101. Let's play it again. Number 10. If you want to collect number 10 from those boxes. Excellent. It's gonna be 8 and 2. 8 and 2 equals 10. So we give number 1 to the box we choose, to the on box, and 0 to the off boxes, the boxes that we do not choose. So we get the code of number 10, 001010. Let's start 11. What will we choose in case of 11? 8, 2, and 1. We give 1 to the box that we choose. We give 1 to the number that gave us the sum of the 11, of number 11. And the other boxes that we do not choose, we just give it 0. As it's considered to be off for us, we are not going to choose it. So what will be the code of 11? 001011. 18. Excellent, we'll choose 16 and 2. And so we give 1 to box 16 and to box 2, and the others, as we do not choose it, so they are considered to be off to us, 0. Is this just a game? No, it's not a game. This is how computer translate numbers. When you enter number 13 to the computer has those boxes in its mind. It's programmed with those boxes with 1 dot and double 1, 2, double 2, 4, double 4, 8, double 8, 16, and double 16, 32. It's programmed like this. So when you enter number 13, how the computer know that this is number 13? It translates to its code, so it knows that this is number 13, so it appears on your screen, or the computer understands that you are entering number 13 by translating number 13 using those codes or those boxes. In page 211, you can find more numbers to be translated, so you can play this game and enjoy your time if you like it. So 0, 1, 0, 0, 1, 1, 1, all of those zeros and ones, what do we call those codes? We know that we have Morse codes, the small codes, the lantern codes. What about the pixels? What about these zeros and ones? What do we call them? We call them binary codes. Binary codes. Bi means two, as they consist of two. Nary means number. They consist of two numbers, 0 and 1. That's why we call them binary codes. So binary codes are the codes the computer used to translate our language, or numbers, letters, dots, spaces, and everything. In your book, you will find that in our digital world, everything needed to be changed into codes. Pictures, words, numbers in our devices are converted into codes. Those 1 and 0, those collection of 1 and zeros is called binary codes. So, will the computer just translate numbers? What about letters? In the binary code, each letter has its code, like A is 0, 1, 0, 0, 0, 0, 0, 1, and so on. Each letter has its own code. Once you enter this letter to the computer or to any digital device, this device will translate this letter in this way, so it understands it and show it to you, or give you, or show you results, or give you your message, or whatever you want to do. For example, my name is Jihad, as you all know. The first letter of my name is J. What is the code of J? How will the computer or the digital device understand the letter J? It will understand it by this code: 0, 100, 10, 10, 0, 1, 0, 0, 1, 0, 1, 0. Okay, but what is the name of each 0 and each 1 alone? It's called bat. Bat and bat and bat and bat. Each 0 and each 1 is called bat. While a set of 8 bats, a set of 8 zeros and ones is called byte. So we all know now that 8 bits equal 1 byte, or 1 byte equal 8 bits. Here you have a video, you can watch it to make this more clear and more obvious to you. And if I enter to my computer the sentence hello, comma, world, exclamation mark, let's see how well the computer translated, or how well the computer understands it. Look here. Let's wait and start with the H. The H code, E code, L code, O code, comma code, space code, W code, O, R, L, D, and exclamation mark. Everything that you enter to your digital device, to your computer or whatever, will be translated into binary code, 0, 1 code. The code that only consists of zeros and ones. And here you are having this activity sheet, you can answer it. You can translate the word love, L-O-V-E, and so on. Now we understand the different codes. Let's see how we share information every day. Like in case of sending emails, sending messages, calling each other. If you want to communicate by computer, like for example, if I'm sending you an email, how will this email reach you? At first, I enter the message on my computer using my keyboard or in my mobile phone or whatever, and then the computer translates this message into the binary code message. Then this message be sent to the modem. the modem or the, you know, the router at your home, the internet router or the modem, then these modems send those binary codes to towers and so on, and then back to your modem as binary codes or binary signals, then back to your computer so you can receive my message and see it. In page 215, we have to put this in order. Kisha wants to send an email to his grandma. We have to put that in order. Which one will be number one? Will be the message played on Kisha's, sent to Kisha's modem, keyboard, grandma modem, grandma computer, or Kisha's computer? Of course, it will start at first on the keyboard, then Kisha's modem. From the keyboard, it will be translated to the binary codes and sent to the modem, and from Kisha's modem to whose modem? I'm sorry, not Kisha's modem, from the keyboard to the computer. You enter the message on the keyboard, then to Kisha's computer, the computer translated to the binary codes. After the computer translated, it sent it to whom? To the modem, and after the modem, it reaches grandma modem. Then after reaching grandma modem, the grandma modem sent it to the computer, so the computer could translate it and grandma could see the message. The keyboard, then Kisha's computer, then to the modem, the internet modem, then to grandma modem, and the last thing to the computer. Here we have to complete this paragraph. When signals are sent from a computer, they need to be in which language? Binary code, modem, or computer? The computer sends the digitalized signals to then these put the signals on the internet. The message first comes to the receivers, first to the receiver's modem or to the receiver's computer. Before it gets to there, think about it and let's see the answers. At first, when signals are sent from computer, they need to be in binary code. The computer sends these digitalized signals, the binary code, the digitalized signals to the modem. Then the modem put these signals on the internet, and the message first comes to the receiver's modem. It go to the receiver modem, then the modem sent it to their computer. Haven't you ever seen those messages on your computer or on your mobile or on any digital device you're using? Errors, errors, errors. Have you ever think why those messages appear like this? Sometimes it means that there was a communication problem between part of the system. Other time it means that the stream of bits of codes need to catch up. You are entering so many information to the computer or to the digital device that can't translate it and it can't understand it. It's not able to translate it all in the same time, so it gets confused and give you errors. Maybe you enter something that the computer cannot translate. It doesn't have its codes from the very beginning. So how could it well translate it so it give you error? This is why error message appears. The digital device cannot translate what you are saying, or you are entering so many information that it cannot translate, or there is a communication problem between parts of the system. There is a communication problem between you and the computer, so it cannot understand and it cannot translate and it cannot do what you want, so it gives you error messages. In page 213, we have to draw a line from the issue to the possible cause. Like here, if we have too much traffic online, will it give us error message or low signal? So much travel online. Too far from the cell tower. You are very far from the cell tower, very far from the place from which you are going to get internet from. Of course, you will lose signal. Computer speed is too slow. Too slow, cannot translate. Error message. Too many phones being used at once. Too many phones use it once, so the computer cannot translate, or the phones cannot translate what you are saying, or the connection cannot help all of those phones together, so it will give you, let's see, too much traffic online, it will give you error message. Too far from the cell tower, of course you will lose the signals. Computer speed is too slow, error message, it cannot translate what you want, it cannot give you what you asked for. Too many phones being used at once, error messages. What about phones? Didn't we communicate through phones? How we do that? I'm here at my home, I pick up my phone and call you, and you're hearing my voice, even if you are in different country or in different place, very far away. How? The phones convert the sound waves, our sound, to radio waves. And then those radio waves be sent to the cell phone towers. There is towers around us everywhere, so the sound be sent to the cell phone towers. Then to the satellite in the space. And then the satellite take those radio waves and send it back to the cell phone tower that's close to the person that you are talking to. Then the receiver cell phone receive the call. This is how we hear our sound, or this is how we call our friends from far distance. At first, our sound waves transferred or converted to radio waves. Then these radio waves be sent to the cell phone towers, and then to the satellite, back to a cell phone towers that close to the person that will receive your call, then to the receiver cell phone, so the radio waves transferred back to sound waves, so you can hear your friend, or your friend can hear you, whoever who's calling the other. How cell phone help us communicate? Can you arrange the picture? Of course, at first you make the call, you enter the code of your friend, and you make the call. Then your sound transfer to radio waves, then be sent to the cell phone towers, then to the satellite, then to your friend's cell phone tower, then the calls delivered. Thank you so much. I'm grateful for watching the video. I hope you understand it quite well. If you have any question, don't hesitate to communicate with us and ask us. Thank you very much. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.